How are you guys? You have little siesta maybe? Little nap, right? Okay, let's get started. So my name is Javier Cuevas. I'm from Madrid, Spain. I'm co-founder and CTO of Gudog. Believe it or not, the guy in the picture is actually me. 8 years ago, I'm really bad at selfies, so I guess that was my best shot in the last 10 years. Before Gudog, I led Diacode for 6 years. Diacode was a Ruby on Rails and Elixir consulting company. We were a team of 5 guys working remotely for startups all over the world. Now, before I get started, I have to tell you something. I have no idea how I got here, like really. I got to speak in a conference with guys from Facebook, Airbnb, Microsoft, PayPal, Amazon. These are people whose products and APIs and libraries I use on a daily basis. And here I am, from a company that probably none of you have ever heard. The good thing is that my company is the only one that is about dogs, so I get the full right to use GIFs of dogs during my talk, which helps quite a lot. I want to thank you, the organizer, for having me here and letting me be part of such an amazing lineup. And huge congratulations for putting such an amazing conference. It feels like you've been doing this for 10 years. So I would like to give an applause to Infinite Red for being here since 5 a.m. in the morning today. So now that you know a little bit about me, here's a little bit about my company. Bulldog is a marketplace that connects dog owners and dog sitters. We started in 2012 and became the first alternative to dog kennels in Europe. We are a small team of less than 10 people. Only 2 of them we are developers, including me. Most of us, we are familiar with the success of big companies using React Native, such as Facebook or Airbnb, but there are not that many stories about small startups choosing React Native as their main weapon to conquer mobile. Since we started Gudog, 90% of our user acquisition has come from organic traffic. One of the factors that helped us achieve an excellent SEO was that our site had a responsive design. And at that time, Google used to boost results for responsive sites. But our first real experience with mobile was 2 years ago. From 2012 to today, we have seen the mobile traffic growing from a 20%. I'm sorry, I'm trying to find my cursor on the screen. Here it is. From 20% to more than 60% of total traffic. So in 2015, we decided to launch our first mobile app. As we had no experience building mobile apps, and we had no budget to hire native developers, we went with the only option available at the time, which was a hybrid app, meaning Cordova, or also known as Phonegap. There are plenty of frameworks to build hybrid apps, but back then the most popular one was Ionic framework, which was based in Angular.js. So we decided to go for it. In only 6 weeks, we had the first prototype of our new mobile app built with Ionic. At the beginning of this year, we set the goal of becoming a mobile-first company. This means becoming an app that happens to have a website and not a website that happens to have an app. So if we were able to ship our first mobile app with Ionic in just 6 weeks, why did we abandon it? When we were developing the first app, we hit our first bottleneck problems because of being running inside a web view. We also learned that debugging a web view on Android below version 4.3 is pretty much impossible, as there is no support for the remote Chrome inspector. Soon after we released the app, for different reasons, we had to focus our little dev resources into the website, which was what was making us money. By the time we decided we wanted to invest on mobile again, we found that Ionic had shipped version 2, which was based on Angular version 2. And as you know, it is quite different from the previous Angular.js. We started having problems to maintain the project as some of the libraries that we rely on, in particular, some Cordova plugins weren't being updated and bugs were not being fixed. It was time to look for something else. We took a look to different options, and this is what we found. We were already using React on our website, not as a single-page app, but for building things like complex form or date pickers. Therefore, using React Native made a lot of sense for us. We realized that if we wanted to be a mobile-first company, we will need to invest in a solid technology that allow us to iterate and ship features with the quality and agility that we are used to in the web. We decided to do what every startup should not do, which is rewriting the whole thing. So in order to put React Native to test before we committed to it, we decided to start creating one of our most tricky components of our application, or date picker. The reason why our date picker is, well, a bit picky is that it needs to be able to handle 3 different scenarios. Date range, composed by a start date and an end date for our dog boarding service, single date for our dog walking service, and multiple non-consecutive dates for our doggy daycare service. Even if we were, even when we were building our website, we couldn't find any date picker that will handle these 3 scenarios, so we had to build one ourselves. Our first idea was trying to adapt our existing React date picker for the web into React Native, but we were still quite new to React Native, and the web date picker was designed to work with mouse events, not with a touch screen. Therefore, we decided to build something specific for React Native from scratch. This is what we come up with. Inspired by the fantastic design of the date picker from Airbnb's mobile app, we built a modal-based date picker that supports date range and multiple dates. Right now, it uses React Native list view component, but we're already rewriting it to use the new virtualized list component. The component is open source and is available at our GitHub repo. The latest version uses style components and theme provider to offer full control over the styling. You can override any style property for any of the subcomponents, which was something quite hard to achieve with an open source component. This is how it looks in our actual app. So to the left there is the dog boarding search, and to the right the doggy daycare. You can see the left has like the date range, and the right one has like multiple non-consecutive dates. After we succeeded building our date picker prototype, it was time to start working on our new app. Little we knew at the time of the amount of decision that we will have to make. To me, starting a new React Native project, or actually any React and Redux project, it feels like trying to do groceries in an American supermarket. You go there with a simple idea of what you want, and you end up overwhelmed with the infinite amount of options for everything. And chances are that you might end up buying a lot of junk food. So the first thing that we had to figure out was how to structure a project. As the only thing that we had for sure about our new project was that we would use Redux for state management. Fortunately, that's something that most of us we have agreed on. We decided to ask Redux first. Redux, well, the Flux architecture was introduced by Facebook as a kind of replacement for the MVC architecture. However, while many MVC frameworks usually gave us some kind of project structure to follow, Flux architecture doesn't do much in that sense. Anyway, we went to Redux documentation, and that's what we found. Not very helpful. On the React world, sometimes it feels like every library wants to do a single thing very well, but no one tells you how to put everything together, right? React is like, oh, I'm sorry, I'm just a big part of the thing. And Redux is like, oh, I'm sorry, I'm just a data store. However, Redux documentation does introduce us to some common patterns for project structure. The first project structure pattern or style is the Rails one where we basically group our files depending on their kind. So we got one folder for our dump components, the one that are not connected to the Redux store, another for the containers or the smart components, and then we have axiom, types, and reducers for the Redux stuff. Some people prefer to add a suffix to its file name so that it's easier to find the file you are looking for when using the fuzzy search on your favorite editor. And you will probably end up having other file types such as saga, selector, and obviously styles for your components and container. So you can keep adding a folder for each file type. You would also probably want to add a test folder, maybe not for writing tests, but just to make you feel better seeing that it's there. Next, we have the domain style structure, where we group files by feature or domain, so that we have a folder for our user screen, for example, with all its action, reducers, sagas, selectors, and so on, and another for our doc component. Its feature folder might contain dump components in addition to the container. It is also common to have a root level components folder with the shared dump components like buttons or modals. Some people like to group things after their database model or schemas, and other people group files by feature or even by screen. Finally, we have DUX. DUX is a pattern that basically aims to reduce boilerplate by putting axiom types, axiom creators, and reducer into a single file per domain or feature. The DUX pattern can be applied to the Rails style that we have seen, and also to the domain style. There are even more patterns, such as the one proposed by Ryan Florence, author of React Router, where the file tree matches the rooters of our application. The main problem with the DAX pattern, or even with the domain style project structure, with or without DAX, is that, as Dan Abramov, author of Redux, points out, it gives you the wrong feeling that having a reducer from one domain responding to an action from another domain is not correct. After learning about all these patterns for project structures, we were like, meh. All of them have some sort of drawback, and it seems that every person has a different opinion about them. Basically, it's like the tabs versus space problem. I'm really looking forward for the next season of Silicon Valley TV show to see them arguing about how to structure Pied Piper JavaScript code. I'm wondering, what do you think, guys? Are you happy with your current project structure? Is it just me who sees this as a problem? So I just created this Twitter poll 5 minutes ago, and I would love to have your opinion. It's pinned, I just pinned the tweet on my Twitter profile. And is this also a way for me to gain Twitter followers? Yeah, maybe. The next question we had to figure out for our new app was how we were going to communicate with our backend API. In other words, how we were going to fetch our data. Let's say that we want to create a screen with all the docs in our database. What do we need beside that React container? We need some redox actions, some action types and action creators. One for when we start fetching the data, another for when we got our results, and another one just in case something goes wrong. Then we need a reducer to update the state of our doc list screen. Well, this is not the actual reducer. I'll let you watch it again because it's super funny. This is the actual docs reducer. I don't know how much you can read from the back, but it's basically quite simple. We just dispatch doc requests. When we dispatch doc requests, we set the fetching flag to true so that we can display a loading spinner or something like that in our screen. Then we need to hook up our docs reducer into root reducer. And finally, we create our store using our root reducer. Now let's create a simple model to call our API. To do so, we are going to use API-Sauce, which is a nice library created by Steve Kellogg, which is somewhere, I don't know where, from Infinity Red. API-Sauce is a wrapper around axioms that let us create API wrappers in a matter of seconds. One of the nice things that we can do with API-Sauce is that it's adding transformer to our requests and responses. Our backend is written in Rails, so all the data our API returns comes with underscore case. Using API-Sauce transformers and a library called humps, we can handle the conversion to camel case in less than 10 lines. Our API is using JSON Web Tokens for authentication. Thanks to API-Sauce, adding an authorization header is straightforward. Once we have our API service, then we need to hook it up with our Redux stuff. As you know, both action creator and reducers are pure functions in Redux, so we cannot do any kind of async stuff in any of them. To do so, we need a Redux middleware. Probably the most famous Redux middleware is redux-saga, created by Dan Abramov, who also created Redux. Let's quickly review how we will reuse redux-saga. Here we have our configure store.js file again. To add redux-saga, we just need to import apply middleware from Redux and thang from redux-saga. Then we add a second argument to the create store function, which is going to be the result of applying the thang middleware. Pretty simple. With our middleware in place, it's time to create our thang. A thang in our context is a function which returns another function that receives the redux dispatch method as an argument. Something like this. Now we can use fetchDoc as we use any other action creator. This function will first dispatch the docs request action and then call our API service, dispatching the proper action depending on the kind of response we get from the API. Probably most of you were already familiar with redux-saga and how to use it, but this is going to be helpful to explain what is coming next. So what's the problem with the redux-saga? Problem is that it's so easy to abuse it. In this conversation between Leland and Dan Abramov, we see which is the main concern, that people abuse it, so we all have started to look for other Redux middlewares. Here is where redux-saga comes into play. First of all, what is a saga? A saga is like a separate thread in your application that is solely responsible for side effects. Notice the like in italics, because it's not an actual thread. Don't think that it's like a JavaScript thread. It can also be defined as a piece of code which runs in the background, waits for dispatch action, and might perform some async or synchronous calls and can dispatch other actions. How do we use redux-saga? So again, here is our configure.store.js file again. Setting up the redux-saga middleware requires a little bit of additional effort compared to redux-tank. First, we need to import the default export from redux-saga with the name create-saga middleware. This is a function that, as its name states, creates the saga middleware. The reason why it's a function and not an object is that, compared to redux-tank, is that redux-saga allow us to pass in something that they call a saga monitor. If you are familiar with Reactotron, this is what Reactotron uses to monitor sagas. Finally, we have an additional line that tells redux-saga to run our root saga. So how does the root saga look like? The first weird thing we see here is that getDocs function has a star next to it. How many of you know what that star means? So not that many, okay. So that star means it's a generator function. Generator functions are a new feature in ES6, and unlike normal function, which runs to completion and return a single final value, generator functions can be paused and resume on demand and can return multiple values by using the keyword yield. Without going into too much detail, the way to read this code is that our getDocs generator function is going to call our API. The generator function will pause until the API call has completed. This doesn't mean that the whole JavaScript thread is going to stop. It's not like you stop the wall. It's just that the execution of this particular function gets stopped at that point. Then, when the API returns our call, we are going to dispatch an action, the success action or the failure action. Note that instead of using dispatch, we are using the put function from redux-saga. The saga middleware will be responsible for transforming that into an actual action dispatch. Finally, we have a root saga where we map the doc request action to our getDocs generator. We also call this generator just sagas, so we can name it the getDocs saga. So we map doc request to the getDocs saga, and the redux-saga middleware will execute it every time the action gets dispatched. There are other Redux middlewares that you can use to achieve side effects or async calls, such as Observable or Redux Promise. If you want to know more about them, you should definitely check this great article by David, sorry, I'm not getting your last name right, from React Native Training. So, shall we use simple and straightforward redux-tank or the powerful redux-saga? Once again, we are still getting the classical JavaScript wall response of use what works for you, which, with all the respect and admiration for Dan, is quite a frustrating answer when you are starting with a new technology. Therefore, as it happened to us with the project structure problem, we were again lost and confused, trying to decide on a Redux middleware for our app. We started looking for boilerplates in order to learn more about these patterns, and that's how we found about Ignite. So Ignite is a CLI created by our friends from Infinite Red, our host today. It used to be sold as the unfair head start for your React Native app. I guess their point was that Ignite gave you so much already done that it was unfair to other people who were starting with React Native too. I remember that tagline got my attention right away, as I could easily relate it to my first experience with Ruby on Rails. I remember winning hackathons just because with a few Rails commands in the terminal, I could get a CRUD for any domain in a matter of minutes. It was totally unfair to other people competing in these hackathons. Ignite used to be a hybrid between a boilerplate and a CLI. Recently, they released version 2, where they focused on the CLI and made everything else optional, starting with the boilerplate. The previous boilerplate has been improved and is now the default option, but you can use something else, or even you can create your own boilerplate and use it with the CLI. Using Ignite is pretty simple. You just install it as a global package and then run Ignite new instead of React Native init. This will create a React Native app with a Rails-style project structure, adding some new folders for things like navigation, themes, or data transforms. Then we can start using the power of the Ignite CLI to generate container, redux, sagas, and so on. So the previous example of creating a list with all the docs of the database could be created with Ignite in less than 5 minutes. Ignite also has by the way, all these files that it's generating, they are not empty. They have like the whole thing like ready for you. You just need to start making changes to them. Ignite also has the concept of plugins, which are a way to bring new libraries into the project, including native libraries that require linking along with new generators. So if you want to use the fabulous React Native Maps library from Airbnb with Ignite, we can just do Ignite add maps, and then Ignite generate map will generate a component with a boilerplate already displaying a map with some fake data. Then we just need to change the data. Ignite's default boilerplate is quite opinionated, and that's something we really like. It allows us to leverage and take advantage of the knowledge of the Infinite Red team, who are working constantly with multiple clients building cool React Native apps. As a Ruby on Rails developer, this is the closest we can get to our Rails experience with React Native, or at least the closest we have found. By the way, I don't know if they have mentioned it, but the official conference app is built with Ignite. Once we decided to delegate on Ignite for deciding on a project structure and a Redux middleware, the next question was how to handle the data that we were getting from an API. Unfortunately, on this matter, Ignite didn't provide us with any solution, so we had to do the research ourselves. In our case, our API endpoint for docs returns 2 pieces of nested data for each doc, the breed and the owner. If our user Anthony had more than 1 dog, his data will be repeated for every dog he has in the same way that for every Jack Russell in the API response, we will have the breed data repeated. We might have the option of updating our API endpoint to normalize the data. However, as our docs endpoint is being used by our legacy app, the hybrid one, we don't want to change it. It might be also the case that you need to use an API that you don't have control over and you are still getting nested data. To solve this problem, we can use Normalizer, a library created by Paul Armstrong from Twitter. To do so, we just define a bunch of normalizer schemas. In this case, a user, a dog, and a breed. They usually look like your database models, and we define the relationship between them. If you have ever used Rails, this is kind of like the has many and belongs to from Active Record. With our schemas in place, Normalizer will transfer our data from an array with nested data into this object with all the entities separated. To hook up redux-saga Normalizer, we just go to our sagas file again. We import our doc schema, and we call the normalize function before we dispatch the doc success action. By doing this, our doc success action object will include a payload with entities keys, storing all our normalized entities separated, doc schemas and users. When using Normalizer, it's kind of common to store all the normalized entities under a single key of our state tree. To do so, we go to a root reducer and we define a new entities reducer that will process any action that has a payload.entities key. This way, all user, dogs, and breeds will live under state.entities. If we want to pass this data in a denormalized nested way to one of our containers, we could also use the denormalize function provided by Normalizer. So on our component, we can do something like doc.owner.name. The next big question that we had for our new app was what to do with navigation. So this is basically a short list of navigation libraries for React Native. We have React Native router flux, which was the one that we were using at the beginning because it was the one recommended by Ignite version 1. But then soon React navigation came up, and it seems to have like a way better support from the whole community. It's the one that is displayed on the official React Native documentation, and it's the one that we are using now. Ignite version 2 is already using React navigation. There are some other interesting options, especially the one from Wix, React Native Navigation, which is like more native. This is kind of weird to say because like every navigation library claims to be native, so you don't know what native means anymore. But the Wix one feels like more native. And then there is also the one from Airbnb, but this is still on beta version, so it's still a bit early to use it. But I will check it out because everything, as you probably have realized, I like everything Airbnb does, so check it out. So far we have seen, I don't know how much you can see from this table, but so far we have seen how we face project structure, side effects, dealing with relational data, and navigation in your app. However, I have only showed you some of the options. In this table, you have all the libraries that we consider for each category. These are not all the available options, just the one that we spend time looking into. The green color means, sorry, the orange color means we ended up using them, and the fire emoji means that those come by default with Ignite's default boilerplate. But to build an actual React Native app, there are a bunch of other things that you have to decide. You need linting and maybe a code style. We started using standard.js, which is the one that ships with Ignite, but as soon as we heard about Prettier, we fall in love with it, so we migrated to it and we combine it with slink config from Airbnb. You might want to use type checking, so the React Native default is obviously prop types, and that's what Ignite offers you by default, but we're already using Flow, in particular in the date picker component that I showed you at the beginning of the talk. Probably you want testing, we are using Yes and Enzyme. Probably you also want immutability. We were not very experienced with immutability in JavaScript, so we just follow Ignite's recommendation and we use seamless immutable together with Lambda. Then, sorry, this is the immutability. Then you might want to use some kind of boilerplate or CLI. As I said, we are using Ignite, but there are other options. You might want to use a UI kit. We opted out for not using any of them because in our case it was easier. We will have to style them anyway, so we just build our own components. But there is a large list of UI kits. And then we have a bunch of other libraries that we use. We have maps, we use Lottie for animation, we use Socket.io for the WebSockets of the chat, we use React Native internationalization, we have vector icons, and we use code push, which is amazing. This is one of the reasons why we went to React Native, was to be able to ship updates over there. So now we have this pipeline, this CA, continuous integration, continuous delivery pipeline, where when our JavaScript build passes, we ship the update directly to the user. So the question now is React Native productive? We built the first prototype of our hybrid app with Ionic in 6 weeks. And it's been months since we started with React Native, and we haven't shipped it to our real users yet. We are planning to do that this month. In my opinion, in the React Native community, we like to brag about how productive React Native is, thanks to things like hot reloading. But where does all those productivity gains go if we have to spend a bunch of hours just to figure out in which folder we should place a new file? I believe one of the most anti-productive things in programming is the lack of confidence. I think lack of confidence is usually a mix of lack of experience and FOMO. Lack of experience to judge whether your decisions while coding are right, and fear of missing out a better way to do what you are doing. I think there is a tremendous opportunity in the React Native space to build something like the Ruby on Rails for the mobile world. We already have all the tools we need. We just need to agree on a good set of best practice and common patterns. So, in other words, starting a real-world React Native project still feels like one of those choose your own adventure books, where on every page you have to choose between a bunch of exciting options, and every time you make a decision, you suffer from the fear of missing out something better. Now it's your turn to choose your own adventure. Thank you.